Hello everyone, my name is B. Chandu. I am here to present the project I worked on during my embedded systems internship. The title of the project is a microcontroller based simulation of a washing machine using PIC16F877A microcontroller and Picsimlab. Let's dive into the introduction. Washing machines are essential household appliances and their automation helps make daily life easier. This project simulates the working of a washing machine using a microcontroller. Our goal was to design a smart, adaptive and efficient washing machine using embedded system concept. Let's know about C and embedded C. C is a widely used programming language developed in the early 1970s by Dennis Ritchie at Bell Labs. C is a general purpose programming language and it is also known as the mother of all programming languages. C forms the basis for embedded C. Embedded C includes features that allow direct access to hardware components like timers, input-output ports, and interrupts. Using embedded C, we wrote programs that control sensors, motors, LEDs, and more in our project. Let's see what is an embedded system. An embedded system is a combination of hardware and software designed to do one specific task. Unlike general purpose computers, embedded systems are optimized for performance, cost, and size. Our washing machine system is a perfect example of a dedicated embedded application. Let's dive into the categories of embedded systems. Embedded systems come in various types. They are real-time embedded systems, standalone embedded systems, networked embedded systems, mobile embedded systems, and hybrid embedded systems. Real-time embedded systems are designed to take action or decision within specific amount of time. They are time-bound systems where time is strictly followed. In real-time embedded systems, there is a chance of loss of property and human life. Further, real-time embedded systems are classified into three types. They are hard real-time embedded systems, firm real-time embedded systems, and soft real-time embedded systems. Hard real-time embedded systems are systems where deadline is strictly followed and there is a chance of life loss. Examples: airbags, peacemakers. Firm real-time systems are systems where there is a chance of property loss. Examples: fire alarms in garments, rovers. And soft real-time embedded systems can accept some amount of delay. Examples are microwave, washing machine. Standalone embedded systems are further classified into two types. They are slave standalone embedded systems and independent standalone embedded systems. Slave standalone embedded system blindly follow instructions given by user. Example: semi-automatic washing machine. Independent standalone embedded system can take decisions by its own without human interference and it has intelligent part in it. Example: Tesla car. In network embedded systems, multiple components or devices are connected together to perform specific tasks. Examples are Wi-Fi based systems like home automation, monitoring systems, and Bluetooth based systems. Mobile embedded systems are mobile and portable. Examples are mobile phone, smartwatch. Hybrid embedded systems have more than one category of embedded systems. Examples are robots, self-driving cars. Let's see microcontroller based washing machine simulation using Picsimlab. Project purpose. Our main goal was to simulate the actual working of a washing machine using Picsimlab. We studied how a real washing machine works, understood parameters like fabric type and load size, and created a virtual model that reflects real world washing machine functionality. Tools required. We used MPLAB XIDE for coding and project management and the XC8 Compiler to write embedded C code. Picsimlab is a simulation tool where we tested and observed the working of our code in a virtual environment. We need to install these three essential tools. They are MPLAB XIDE, MPLAB XC8 Compiler and Picsimlab Simulator. MPLAB XIDE. The IDE which we will be using for embedded systems development with PIC MCUs is called MPLAB XIDE. It is product from Microchip which is so powerful and versatile. It is used to create new projects and helps to write the assembly language program for interface. MPLAB XC8 Compiler. MPLAB XIDE by default does not include any compiler. We can use to write code in embedded programs without the need for any compiler. But if we want to write code in embedded C language, we need to install a separate compiler. Hashtag include xc.h header file contains the definition of all registers of Pix16F877A microcontroller. After we finish writing the program, we will need to compile the code to generate the hex file and to if there is any error in the code. To compile code, click on build option. If there is no error in the code, it will display a message of successfully built and generate a hex file. Picsimlab Simulator. Picsimlab is a real emulator of development boards with MPLAB X debugger. Picsimlab supports several devices that can be connected to the boards for simulation. Let's know about Pix16F877A microcontroller. This 8-bit microcontroller was chosen for its flexibility and ease of use. It has flash memory, RAM, EEPROM and supports multiple interrupts. It's ideal for real-time embedded applications like our washing machine. Let's see the components of this project. Tactile switches. Tactile switches are used as input devices. We mapped different switches to different actions like navigation options, starting or stopping the machine, and checking door status. They are user-friendly and commonly used in digital devices. CLCD. The CLCD was used to display messages to the user. For example, during a washing cycle, it shows the current operation or water level. A 16x2 LCD can show up to 32-bit characters in 2 rows, making it perfect for user communication. Keypads. The keypad allows user to give input. It can be level or edge triggered. In our simulation, it's used to select wash modes, enter settings, or control functions like start or pause. Timers. Timers are essential in embedded systems for scheduling events. Pix16F877A has 3 timers. We used them for creating time delays between washing phases and for PWM signal generation when required. Interrupts. Interrupts allow the system to respond immediately to events like door opening or pressing a button. We used both hardware and software interrupts in this project to improve real-time responsiveness. Buzzer and fan. The buzzer is triggered at the end of the wash cycle or to indicate alerts. The fan helps in drying and stops if the door is open. These simulates a real-time feature used in dryers, washing machines. This block diagram shows the interaction between the microcontroller, input devices like switches and keypads, and output devices like LCD, buzzer and fan. It gives a clear overview of the system architecture. In the demo, we simulate the washing process virtually. You can see how the machine transitions through stages. Let's see the programming section of washing machine project. In the header file section, we include CLCD.h, digital keypad.h, main.h, timers.h, washing machine function definition.h. CLCD.h is for liquid crystal display. For display purpose, we use the CLCD.h header file. Digital keypad is for inbuilt keypad which is in Picsimlab tool. For that purpose, we use digital keypad.h file. We use timers.h to control the timers. And we have write the program in washing machine header function .c main file. This is the program for washing machine. This is the main file. Here I have open MPLAB XIDE editor where I have created the project called washing machine, and I included the header files and source files. Coming to the header files, I included CLCD.h, digital keypad.h, main.h, timers.h, and washing machine function definition.h. And source files included are CLCD.h, digital keypad.h, ISO.h, main.c, timers.c, washing machine header function.c. To compile this, I have selected the build main project and the compilation process is ongoing. For successful completion, it displays build main project successful and gives the path. By using the path, we used to load the hex file in the Picsimlab tool. Opening Picsimlab tool, firstly we have to change the clock frequency and board and microcontroller. Clock frequency should be set to 20 MHz and we have to select the board called PicGenius, and the microcontroller we have to select is PIC16F877A. Now we have selected the clock frequency as 20 MHz and board as PicGenius and microcontroller as PIC16F877A. We have to select the LCD which is 16x4. We use fan instead of motor to know the working condition of washing machine. If fan is rotating, it means the washing machine is in on position. If fan is off, which means washing machine is in off condition. Initially, the LCD displays 4 lines. They are: press key 5 to power on washing machine. We use switch 5 to power on the washing machine. Switch 5 means RB4. We have to press the RB4 to power on the washing machine. It displays powering on washing machine, then it automatically displays washing programs. Here we seen so many options like rinse plus dry, dry only, wash only, aqua store, daily, heavy, delicates, whites, and I am going to select the heavy option. To select the heavy option, I have to long press the RB3, which is switch 4. To navigate, we use switch 4. To select the option, we have to long press for more than 3 seconds to select the option. By pressing the switch, I have selected the water flow as maximum, and the program going to start, and the LCD displays the functional screen which contains function, time, switch 5, switch 6, where function shows what we have selected, and the time is displayed, which is decremented continuously. Switch 5 is used to start the function, and switch 6 is used to stop the microcontroller, which means the washing machine. Switch 5 is to start the washing machine, and switch 5 is to stop the washing machine. Here we use switch 1, which is RB0, to represent the status of door. By pressing the RB0, the washing machine understands that the door is open, and it displays that the door is open, please close the door. By releasing the RB0, which means switch 1, it displays automatically the functional screen. We use switch 6 to stop the washing machine. We use switch 5 to resume or to restart the washing machine. When time comes to 0 seconds, then the LCD displays program completed. Please remove clothes. In Picsimlab tool, we have inbuilt keypad and LEDs. LEDs are showing different options by blinking. We use RB0 as switch 1, RB1 as switch 2, RB2 as switch 3, RB4 as switch. To select the options, we have to long press switch 4, that is RB3, for more than 3 seconds. After the LCD displays water level, we have options like auto, low, medium, and other options. By using switch 4, we can select the options what we want. Then the CLCD displays press switch 5 to start and switch 6 to stop. If you select start, we can observe the fan is rotating, and the CLCD displays the function screen, where we have the function, time, 5 to start and switch 6 to pause. By pressing switch 6, which is RB5, the fan is stopped, which means the washing machine is in off condition. To resume it, we have to press switch 5 to start the washing machine. Fan rotating means washing machine is in on condition, and fan not rotating means washing machine is in off condition. The time in the function screen is decremented continuously. As it reaches to 0, it means the program is completed, and in LCD display, it displays that program completed and remove clothes. And we use switch 1 for door status. Coming to the conclusion, this simulation project gave me valuable practical experience where I have applied theoretical knowledge of timers, interrupts, and peripheral interfacing to build a working model of an embedded system. It also demonstrated how automation enhances performance and user experience. Thank you all for listening.